A lot of people would know what Starburst lollies are, right? Juicy bursts of flavor that pack a punch. Also, many of us have run an SQL star query, pulling in everything, hoping to make sense of an overwhelming amount of data. But as data continues to grow and explode in volume, orgs need something more powerful, something that brings all those diverse data sets together seamlessly. Enter Starburst. Today's guest on episode 86 of Great Things with Great Tech is Justin Borgman, co-founder and CEO of Starburst. Starburst leverages technologies like Trino and Apache Iceberg to offer high-performance data warehousing and analytics without the need for traditional data warehouses, enabling organizations to derive actionable insights from their data more effectively. This is Great Things with Great Tech, the podcast highlighting companies doing great things with great technology. Don't forget to head to YouTube at GTWGT Podcast or on all good podcasting platforms. Subscribe, follow to make sure you never miss an episode. And now, episode 86 with Justin from Starburst, the data management and analytics company. All right. Hey, Justin, welcome to the show. First and foremost, I'm really interested in your background. Obviously, we're going to get into Starburst and everything, big data and data science. 'Cause I think it's such a critical part of, IT and enterprise today. Data is getting more and more critical, but I'm really interested in hearing about your own background and how you came to co-found and be the CEO of Starburst.
Yeah, sure. Great to be here, Anthony. Thanks for having me. My journey in big data really goes back probably almost exactly 15 years now to the founding of my first company, which was called Hadapt, and that was back in 2010. And that was a SQL engine for Hadoop. So this is the early days of Hadoop. Hadoop was really the first data lake, and what we were trying to do at the time was really turn this data lake into a data warehouse. And so Hadapt was this SQL engine that would take SQL queries and process them on data living in Hadoop. And that was the spin out from Yale University. We raised venture capital, built that business over a few years. And then that was acquired by Teradata. And I
Okay.
ended up spending a few years at Teradata. And my job at Teradata was kind of interesting because I was sort of responsible for figuring out the future of data warehousing analytics. And in that context, discovered another SQL engine at Facebook, actually. There was a
Oh,
very
okay.
early open source project, originally called Presto. Today it's known as Trino. And essentially, got super excited about the potential of this query engine. It allows you to run really fast SQL analytics as well as query data and other data sources as well. And so we started investing in that very heavily while I was at Teradata. My team became some of the leading contributors to the open source
Okay.
project. And that led us to ultimately leave Teradata and form Starburst as the company around that. And the creators of the project left Facebook and joined us and became my co-founders.
That's awesome. So obviously, data and this data science has been a part of your world for the last 15 years. But interested, how did you get to that point? Like, what led you to sort of be really interested? We'll talk about Hadoop a little bit later on because I touched that a little bit in a very different way back in the day as well. But yeah, what led you to sort of have this passion for this sort of big data lakes and the warehouses?
Yeah. I mean, to me, it's very clear that data is, some people say the new oil. I would even go further to say it's sort of the oxygen of businesses
That's
today.
that's good. I haven't heard that. That's a good one.
Yeah, I mean, I think we're all data-driven businesses at this point. We use our own technology to run our own business more efficiently and more effectively. There are just so many sources of information that we can now leverage to make better decisions, tailor and personalize our services to customers, and so forth. And so to me, this is going to be a multi-decade area of relevance and investment and innovation, and that was really exciting to me. And to be able to play the role of disruptor in a space like that is also really fun and exciting because really databases have largely played the same playbook for maybe 40 years, which is
Mm.
get all the data into the database. They're all proprietary historically, Oracle, Teradata, et cetera. And then you're sort of locked in. And the bills go up And the only way you can analyze the data is to get it back into this central database or data warehouse. And so I think that that model's changing, and that's very exciting to me to play a role in turning that model inside out, which we'll certainly get into.
Yeah, that's interesting because I guess what you're talking about, and when I think about databases, they are very much, in the old days, MS SQL, Oracle, PHP, and all those modern ones. But really, it was all about, yeah, you're locked in. You choose a database, and then that's what you lock yourself into almost forever, right? Like that becomes, where the data lives. And I think today we've seen data just explode across all sort of different platforms, different mediums, and it's actually the storage of today. I've used this a couple of times on the show. I had someone on a few years ago that said to me, these DevOps guys, when they are growing up and learning their trade, when you ask them what storage is, they'll say it's a database or even a table level, right? They don't think about storage or the underlying layers. So it's
Right.
super critical there. What was your background in sort of education and whatnot to get you into this sort of area?
So I did major in computer science in undergrad. I became a software engineer. I did that for about 6 years. Then I worked for a small startup in a product management role, and then decided to go to business school. And the
Okay.
logic there was just I wanted to be able to have a bigger impact. I wanted to sort of understand how the little work that I was doing, as an early software engineer in my career, how that could impact sort of the bigger picture. And so got my MBA, and it was really while I was in business school that I guess the inner nerd in me decided to go see what was going on in the computer science department. And that's really where I met my co-founders of that first business. They were researchers who had written a paper called Hadoop DB, which was
Okay.
basically the pioneering thoughts around treating Hadoop as a database or data warehouse. And that ultimately began my journey in entrepreneurship and bringing that technology to market.
Yeah, and just I think you mentioned data lake and data warehouse. So just explain the difference there. So database, data lake, data warehouse. I think that's important to level set when we talk about more about what Starburst does.
Yeah, absolutely. So, um, a data warehouse generally refers to a read optimized, so sort of designed for analytics, not for necessarily transactions, but for analytics. Central warehouse with central database essentially. So it's Teradata is sort of the classic example. Oracle's Exadata product would be another good example. But all the big players basically had a traditional data warehouse, and the idea was your business starts to develop these data silos. Wouldn't it be great to pull all the data together into one place to understand your business more holistically, to be able to market to your customers, pulling in your marketing data and your billing data and that sort of thing. And so that was really the model that grew up in the 80s and 90s, I would say, primarily. But in the 2000s, the scale of data started to make that a lot more challenging, particularly with the internet companies. If you think about
Yeah.
Google and Yahoo and companies like that, that simply just could not fit the internet into one single database. And so they needed a different approach. And that's really where the data lake comes to be with the creation of Hadoop. Hadoop was the first data lake.
Mhm.
It was, of course, built at Yahoo by reading a paper that actually Google had written. So they both had a very similar approach here. And it became a way of storing data in really cheap commodity storage that could scale out to basically infinity. So no scalability barrier.
Mhm.
And then a separate sort of processing layer for how you would interact with that. And in the earliest days, it was something called MapReduce, which was super
Yeah, I
slow,
remember. Yeah.
crunch infinite amounts of data just very slowly. It would take hours. And then we've gradually evolved since then to, fast forward for a moment to today, where you can really get data warehouse performance out of your data lake. And that's what's so exciting now, 15 years later.
I get it. Yeah, and I had a early interaction with Hadoop, but it wasn't because I was looking to do anything specific with the data or whatever it was. But just as a technologist, I remember VMware released their own Hadoop cluster technology. So they had the download, you'd install it, would create a couple of nodes, and it would basically install the Hadoop cluster, and you'd be able to do some map produce stuff for something, right? And so
Yep.
that's about where I started, and that was, I've got to say, that was maybe early 2010s potentially, maybe even late 2000s. But yeah, so it was around that time when it started, and I guess I didn't realize that, that what I've realized now through the research and doing this, and now thinking about other companies in this similar space to you, this is the evolution of that data lake, and that's what they really talk about. But then that you've got to be able to take that data, and it's not necessarily going to be used in an efficient way for businesses to get the most out of it, right? And that's where you guys come in, and that's where the query engine, the SQL analytics comes over the top of it to be able to make the best of both worlds and surface that data in a really quick and efficient way.
That's right. That's exactly right.
Awesome. So, talk a little bit about Starburst, the founding of it. I'm interested in the name. Where'd the name come from? I'm thinking, of the fruits, but I don't know if it's going to have a link to the Starburst fruits. But yeah, how'd that come to
Yeah.
be?
Yeah. It's a common question. Obviously, yeah, we're not the candy company, but we're very popular. Around Halloween and things like that. Um, but no, yeah. So the name comes from really two things. First of all, naming a company is a hard process for anybody who's going out there and trying to do it. You've got to come up with something that you know uh, will be memorable and also is not taken already by somebody else.
Mm,
Uh, so that's always a challenge. But for us, I think at the core of what we do, we're able to get access to all of your data, and we do it very quickly. And so the reason star and burst were meaningful to us in that regard is in the SQL language in SQL, select star means give me everything.
okay.
And so we like the symbolism of star as a sort of signifier of the reach and the breadth of data that we can touch by virtue of having these connectors to all these different systems. And then burst because we do it faster basically than anybody else. And so we can get all of your data very quickly was sort of the motivation. And we thought, hey, it sounds good. Some people think about the candy, which generally has positive, connotations to it.
Yeah.
So yeah, so it was a lot of fun.
No, that's awesome because obviously, I've run a few SQL queries in my time, and typically I will use the star because that's all I'm good at. Just getting everything and
Yeah.
then you know working it out through there from a table. So yeah, it's actually almost, I wouldn't say it's like disappointingly logical, but in a good way. You know
Yeah.
what I mean? Like it just makes sense that you've named it that. So no, it's a good name and it fits. So tell me about what's the value prop, and what would the mission statement be of Starburst?
Yeah. So it's really that we provide data warehousing style analytics on data that lives anywhere. And what that means in practice is really two things. Number one, and one of the reasons people think of us is we're pretty unique in our ability to federate queries to multiple data sources. So you might have data in a MySQL database, and you might have data sitting in S3 and Amazon, and you might want to join those two tables for your analytics. And we can actually do that ad hoc on demand in a query and do that very quickly and efficiently. So you don't even need to move data. You don't even need to run it through an ETL process. You can just query it. And so that's one thing that makes this pretty unique. But the other thing, which actually represents probably an even bigger share of our business, is that because we can query anything, some of these open formats in the lake have become wildly popular, specifically Iceberg. Iceberg is an open format that was originally created at Netflix. It was created to pair with actually our open source query engine. So you could use our query engine to query Iceberg. And these were sort of like the two parts to a data warehouse. There's like the query engine part and the storage engine part.
Hmm.
And what's nice is today these are now decoupled. So you can actually mix and match those components, but it's a very natural combination that we see in the open source community all the time. And it's a great way of storing data at tremendous scale for very low cost. I mean, almost nothing, because you're really, if you're thinking about AWS for a moment, like you're just paying for S3, which is
Yeah.
pennies basically, and you can basically develop the lowest cost, high performance data warehouse system or data lakehouse, as some people call it now today, by leveraging, Iceberg as your storage and Starburst as the query engine. So those tend to be the two angles where customers bring us in. Is either I want to build, this scalable, low cost, data lakehouse, or I want to be able to maybe also join data with data that lives elsewhere as well.
Yeah, so the problem of data sprawl and siloed sort of data sources effectively is what you're trying to solve here, because if you've got traditional platforms wherever they may be, modern, storage and storage platforms somewhere else, you don't want to sort of costing, well, the moving of them is expensive, right? In many ways, time, effort, network, bandwidth, whatever it might be. So you want to basically have a layer on top of it. If I'm trying to simplify this as much as possible,
Yeah.
you've got a layer on top of that, which basically can go in and say, okay, well, I know how to talk to all these multiple data sources with my own tech, with the engine and the query engine. But also, if I need to, I've got this Iceberg technology as a storage platform as well, which is a table open table format, right? Which Netflix
Mhm.
invented. So how does
Yep.
when you've got data sitting in, say, S3 or in an MS SQL database, where does
Yep.
Iceberg then fit into that?
Yeah. So the way we think about the evolution, if you will, of the data landscape is we think every customer is going to have a data lake. They're going to have other databases too, but they're definitely going to have a data lake. And the reason simply being that the economics are going to make it highly advantageous for you to have a data lake for a large portion of your data. And so that data lake will likely store data in Iceberg in the future. And we would recommend that you do that. And one of the reasons being that when you store it in Iceberg, you as the customer, as the user, you own the data. We don't own it. Databricks doesn't own it. Snowflake doesn't own it. Google or AWS doesn't own it. Like, you truly own it. It's an open source format, but you can now play all of us actually against each other to compete for the compute. And if we're competing for compute, like, you win as the customer, right? Anytime there's competition, that's good for you as a customer. And that's the beauty, really. One of the biggest benefits, I think, of using Iceberg for a customer is you now have optionality across the different engines that you choose. And so we want to compete for that. We're the youngest and hungriest of the three companies: Databricks, Snowflake, and Starburst. So we're happy to win on price and compete for that Iceberg SQL analytics. Now, to answer your question, what makes us also unique is that data living in MySQL. We can connect to that as well, or that SQL Server database. We can connect to that as well, and you can now incorporate that in your analytics without having to move it. And so the world we see is one that will become lake centric, with other purpose-built databases, outside of that lake, that you want to join in as needed for the types of analytics or reporting or workloads that you're doing.
Okay. And how does how do your products, so you got Starburst Galaxy and Starburst Enterprise. So
Yep.
where do they fit? How are they sort of package up, and what componentry do they have, in terms of what we've been talking about with the iceberg and the analysis layer and all that kind of stuff?
Yeah. So Galaxy is our cloud hosted solution, which means that we manage all the infrastructure. We make it as easy to use as possible. And it's really intended to be a complete turnkey, end to end. We call it an ice house. It's an iceberg warehouse, basically, where we
Okay.
can ingest the data into Iceberg tables. You can connect to, like, let's say, a Kafka stream, or load data into an Iceberg table. We'll do the data maintenance. There's something called compaction that you want to do with Iceberg tables, where you want to take lots of little tables and bring them together, and you get performance advantages out of doing that compaction. That's built in. So we kind of take care of all the plumbing and the heavy lifting, I guess you could say, under the covers, to deliver a really easy to use end to end solution. And so that's Galaxy, and there's a free trial. You can check it out if you'd like. And then Enterprise is self-managed, which means you're basically just getting the software from us, and you can run it anywhere. You can actually run it on-prem. You can work across hybrid environments. So a lot of flexibility with that platform. It can work with and integrate with whatever, security, Kerberos, LDAP, you name it. So it's kind of like, do you want to buy the components to the car and build your custom car? You'd use Enterprise. Or do you want to build something that just works? Maybe it's a Tesla. You just hit the
Yeah.
gas and it works.
Yeah, exactly. Actually, funnily enough, I tried to start a Tesla a couple of weeks ago. I had to Google it, and I was quite embarrassed that there was no start button or anything like that that I was looking for. As a side story, it was just press the button and go. And to your point, like it just kind of worked, right? Didn't have to do
Yeah.
anything. Um, talk a little bit about Trino, because I think that's an important thing. You know, it's an open source project which you guys contribute to. In fact, probably I think you're the leading contributor, right? So talk about that and how that fits into this as well.
Yeah, so my co-founders Martine, Dane, and David are the creators of Trino. Again, its origin story was Facebook many years ago, a little over a decade ago now. But over the years, over that decade period, the community has grown so large. It's now tens of thousands of users and participants in that community. Um, and it includes some of the largest, most sophisticated data-driven organizations in the world, like Apple and LinkedIn and Lyft and Netflix, which we mentioned earlier. So it's got a really wide, I'll say, contributor base from some of these incredibly sophisticated companies. Bloomberg being another one. And the beauty of that, the beauty of leveraging an open source engine is not only do you get the benefits of all these contributions. For example, the ride sharing companies, most of whom use Trino, created the geospatial functions. Like, actually, we didn't create those functions; they did, because they needed it for their business. And so now, Grab Taxi in Singapore and Ola Cabs in India, they use Trino as a result, because it's got all these geospatial functions. So you get that
Okay.
benefit of the community contribution, but you also know, back to that idea of optionality, you could always stop using Starburst and just run with the open source. So that vendor lock-in piece was really a big part of why we founded the company. We wanted to give customers the choice, and that just raises the bar for us to continue to deliver value above and beyond the open source to hopefully keep you as a customer. But you always have that option, and I think that's very powerful as well.
Yeah, because in a certain way, you're looking to kind of democratize the data and make sure that there's an element of it not being locked in, right? Um,
Yep.
Data freedom is something that I know that we talk about a lot at Veeam from a different angle, but it's important because, to the point we made earlier around the original sort of database structures and the way they worked, where they kept all the data pretty much locked away. This is almost an opposite to that, and what you're adding is those layers on top to really make the most out of the data, right? Like that's what I see. So, in terms of the use cases, what are some of your typical, say, if a company comes to you and they've got a bunch of data sitting across marketing orgs, engineering, whatever it might be, and they come to
Yep.
you and say, "Hey, how can you help us? How can Starburst help us make our data valuable to us?" What would be your sort of value prop to them?
Yeah. So very often, an early use case might involve a large set of data in a data lake. Again, maybe it's S3 or Azure Data Lake Storage or Google Cloud Storage or object storage on-prem. We have a partnership with Dell now, where you can buy a Dell Lakehouse, which basically has their object storage with Starburst in it. So wherever your data may be, it very often starts with a large lake, as well as perhaps joining data in some other database. So I'll give you a few examples. One of the easiest to explain is Comcast, which is a large cable TV provider and internet provider in the United States. And when they first started working with us, they had basically all the TV show data. Every time you change the remote control and switch to a different show, that gets captured in the cable box and sent back to this massive data lake. And so they have all this event data, basically, of every time you change the channel, which is really interesting to understand customer behavior. But in a totally different database or data warehouse, they had the billing data, how long you've been a customer, how much you spend every month, what package you subscribe to. And they wanted to join these to understand how customer viewing behavior, the shows that you watch, influences the customer lifetime value and the packages that you purchase, and really enable cross-sell and upsell based on the shows that you watch. And so this was a really big deal. This was like 5 or 6 years ago that we first started working with them, and has been able to allow them to generate a lot of incremental revenue by positioning the right packages, the right products, the right additional channels you could buy
Okay.
based on shows that you watch. Does that make sense?
It does, and actually, to be fair, I would have thought that if I was looking at that outside, I'd go, well, there's got to be a bit of AI or ML in that, just to bring that. We haven't talked about that. It's amazing to have a conversation today and not talk about that
Yeah.
until now. But is is that part of it, or is this like, are we doing that without that because of the technology that you guys have got, or is there an element of that in there for that? Because whenever I think about that, whenever I think about the way that my grocery company that I visit every Wednesday tells me every Wednesday morning what to go buy based on my previous sort of purchases, that it's based on some sort of AI and ML, but it doesn't have to be from what I'm hearing.
Yeah, yeah, exactly. I mean, I think of AI and ML as almost a spectrum of sophistication. Some are just very algorithmically driven. You can do that with Starburst, and then you've got like LLMs and ChatGPT, generative AI on the other end of the spectrum. We think we play a role across that spectrum by bringing the data to the surface for the company that wants to leverage it. And in
Get
some
it?
cases, yes, it's very algorithmic and sort of rules driven, and we can handle that entirely. In other cases, you may need to pull the right data sets together, do some transformation to prepare it, and then run an ML model on it, or leverage it in a model. And at the core, your models are really only as good as the data you train them on, and that's the role that we think we play here, is sort of the plumbing to get you the data that you need in the format that you need to go do those sophisticated analyses.
That's a really good way of putting it, actually. So there's a value prop there that's separate to what we're seeing out there in the hype world. You guys are surfacing that data, bring it to the surface, and allowing the LLMs or whatever it might be to actually do their thing separate to what you guys are doing, which is that, you know, bringing together the meshing together of the data and making it valuable at some point.
That's right. And I think, that's it seems to be exactly where we are in this AI journey, is customers wanting to leverage their own data to create proprietary advantage
Mhm.
with AI. I view ChatGPT as more of like a POC or a demo vehicle, because it's trained on the internet. Everybody has access to it. It's the same for everybody. I think where you really win as a company is where you take advantage of that core technology, but start to train it on the data that you have, and enriching it with the data that you have.
Yeah, that makes absolute sense. So key componentry in terms of, if you look at it, so data ingestion, governance, management, there's capacity management as well. Like how do those play into what you guys do as well? Especially the capacity management. I'm interested in that because that's all about scalable compute and auto scaling typically, but how does Starburst fit into that world as well?
Yeah, absolutely. So at the core of what makes that elasticity possible is this storage compute separation that we touched on, earlier. Again, traditional databases, traditional data warehouses, where storage and compute combined. If you bought a Teradata data warehouse, it had compute, it had storage, it was
Hmm.
all in one box. But as these early data lakes were created, as we were speaking about, by the internet giants, this notion of separating these two became very important. And in the cloud, that really made this mainstream. And what that allows you to do is, again, we'll just use Iceberg as the example here. Store all of your data in Iceberg, and then your Starburst cluster, your Trino cluster. You could have that scaled down to zero. You could scale it up when you need it. You could scale it up based on the CPU processing, and how much load it's putting on your servers. Like, oh, okay, wow, I'm getting all these queries coming in now. All of a sudden, maybe I should start to make it bigger to improve my performance. So you can really be very refined in scaling that to what you need, and then ultimately only paying for what you use. That's the other beauty of cloud computing environments, is they're pretty much utility models. We price the same way, so
Yep.
you're only paying for what you use. Now, I will say the contrast to that is, interestingly, in our on-prem business, and again, I mentioned Dell is a great partner of ours. There are some customers that want to basically uh, prepay for all of that capacity and amortize that over 3 or 4
Yeah.
years, what have you.
Traditional way of doing things. Yeah.
Exactly, and so both are viable depending on what you're trying to solve for.
All right, good stuff. And the governance piece, I think that's interesting as well. Obviously, data, can be dangerous. I mean, I love the oxygen analogy. I might steal that
Sure.
later on. I've actually used the analogy of data being like uranium, like being a little bit dangerous, in the wrong hands and all that kind of stuff. So that was
Yeah,
my thing. But yeah, the oxygen thing totally works as well. It's really cool. But from a governance perspective, so data has gravity. We all know that. So how does Starburst help in the governance side of things?
yeah. So, our vision is to really play the central point of access to all of your data. So that would mean the queries come into us. We access the data wherever it lives. Maybe 80% is in a data lake in Iceberg, and maybe 20% is spread out among 10 other databases. The goal is that the end user shouldn't actually care where the data is stored. They're just joining table A and table B. And in order to make that work, and especially work within regulated enterprises and financial services and healthcare, two of our biggest verticals, uh, access controls become really key. And specifically, what we call attribute-based access controls. So very fine-grained, row level, column level, data masking, being able to tag data. This is PII data. This is, HIPAA data. This is, GDPR data. Whatever the case may be, and controlling that access in that single point. So it's sort of a single point of access and access control across potentially distributed data, and that's really important. So that's been built into our product really from the beginning,
Mm.
and today we serve some of the biggest banks in the world.
Yeah, and more from the point of analytics, right, and querying, as opposed to I've had other sort of global file system companies on this show. I actually had one a couple of weeks ago or a couple of episodes ago. That's not what you're talking about here, right? You're
Right.
talking about the ability to have the overview for the analytics and analysis part.
Exactly at the query level, basically
Yes.
for the end user who's trying to access that. That's right.
Cool. Hey, I just wanted to touch on data science as a general thing, right? Like, obviously, this is a different area of IT. Traditionally, people who are in infrastructure who aren't sort of data scientists, probably find it a little bit hard to make this jump across to this world. So, what, in your opinion, being the CEO and obviously involved in hiring and people and whatnot, what makes a good employer for a company like yourself? What attributes do they have to have from a technical point of view?
Mhm. I think first and foremost, and this is true for probably most roles in tech, a commitment to continuous learning. Like this space is evolving so quickly that even if you're an expert today, you won't be, a couple of years from now if you're not continuously staying sharp and up to date on the latest technologies. And that's even more so true with everything going on with AI right now today.
Mm.
The techniques are changing, the models are changing. So I think that's just a kind of an intrinsic curiosity and desire to learn, that I would look for. The next thing that I would say, just in terms of bringing maybe the skills to bear to be productive here, there are a few ways to tackle this, and maybe you tackle it through all three. One is you can certainly learn programming languages. You can learn Python. You can learn Scala. And that takes some effort and investment. You could also focus on SQL as a language,
Mhm.
which is actually a much easier language to learn, and will not go away. Like that's one thing I'm sure of
It
is
has not gone away yet.
exactly. That's the one constant in 40 years of database history. So your time is certainly well spent investing in it, and as you mentioned in the opener, like you'll learn to be at least uh, you know, uh, you'll learn enough to I guess be dangerous, as people say, pretty quickly. In navigating your data through SQL. So I think that's a worthwhile investment. And then the good news for people who don't even know SQL, over time, you're going to see more and more natural language to SQL interfaces. In fact,
Mhm.
we've built this now into our product. I would call it sort of a beta version today, but it's continuously refining, which means you could express your query in English and say, show me last month's sales data, and it will turn that
Yes.
into an SQL query. So
Yeah.
that's really, I think, the last mile in democratization, as you were speaking of.
Yeah, and actually, to be fair, I've actually got some of those specific companies doing that lined up for the show over the next few episodes, right? Which is really interesting. It just seems to be sometimes you clump like companies together, right? But yeah,
Yep.
I guess that's a really interesting way of being able to naturally prompt an LLM or something to say, hey, I want to get this amount of this data out of this data set. I don't know SQL, but do it for me. So I think that's a really cool way for people to come into it. But obviously, the data scientist role in itself, that seems like a very specified role, right? Like how does one sort of become a data scientist?
Yeah. Um, yeah, I mean, I think there are, classical paths of, going to college and getting degrees in statistics or, anything very quantitative. In fact, some schools now actually have data science degrees, so you could
Mm,
actually literally major in data science. But I think you can also learn these skills outside of that. I think there are a lot of great classes available to study the basics of how to be really data driven in your analysis. Learning about linear regressions and just basic probability and statistics, sort of the language of data, if you will.
yeah.
I think is accessible to you. And then try to get involved in something that allows you to sort of showcase those skills would be my advice. It could even be a nonprofit or a public data set that you start to work with. And I think that's a great way to maybe showcase your abilities as well.
Yeah, it makes sense, right? So a lot of maths basically in the short way is
Yeah.
talking about that, which absolutely makes sense in that point. Hey, I've only got a couple of minutes left. I'm interested in, where is Starburst going? What's the innovation for the future? What's the next big thing for you guys?
Yeah, I mean, for us right now, I would say a big focus is doubling down on what we call the ice house, this iceberg warehouse, for the simple reason that a few weeks ago, both Databricks and Snowflake mentioned they're going to support this as well, and that really gives customers the opportunity, as I said, to store their data in this common open format and then choose the best engine to query that. And that's where we really want to be aggressive right now. We see a lot of opportunity there. A lot of customers are feeling the pain of costs or feeling locked in with their traditional cloud data warehouse or data platform. And we want to provide a more open alternative. So we're going to invest in basically making Iceberg easy. And that's really where our focus is probably for the next couple of years. And then we'll go from there.
Awesome. So Iceberg is definitely the future is what I'm hearing here. And it's almost sounding like Iceberg is the new object storage.
Yeah, yeah, exactly. I mean, it will be ubiquitous. That's a good analogy because even on-prem object storage is now S3 compatible, right? Everything has the S3 interface. The S3
Yeah.
interface seems to become the standard. And I think similarly here, Iceberg becomes the standard table format.
That's awesome. So yeah, so if you haven't looked at Iceberg, you haven't heard of Iceberg, now you're going to hear about it later. If you're in IT, that's what I'm getting out of this. So hey,
Absolutely.
thanks for being on. I think it's been a really interesting. I love what Starburst are doing. I love the whole journey that you've taken, and a really sort of level set explanation about data and how you're leveraging it for the benefit of businesses because make no mistake, data is just going to keep on growing, and we need to be able to make it work for businesses rather than just sitting there doing nothing. So, really appreciate you being on the show.
Thank you, Anthony. It was a pleasure.
Awesome. Thanks a lot. Hey, just as a reminder, thanks for listening in to episode 86 of Great Things with Great Tech. Please stay tuned for more episodes where we continue to highlight companies doing great things with great technologies shaping our world. Don't forget to follow us on social media at GTWGT Podcast and follow and visit gtwgt.com for more great content on all past episodes. If you enjoyed this episode, make sure you subscribe to your favorite podcast platform and on YouTube. Please spread the word. And if you feel like it, drop a review. Tell your friends. Thanks for joining us, and we'll see you next time on Great Things with Great Tech.